Welcome everyone. For today's prep, we're going to move into our next section and we're going to start looking at some more advanced differentiation rules. And the ones we're going to look at here we're going to start looking at is the product rule and the quotient rule. So let's start with our product rule. So here's the formula. And we're going to, maybe we can remember the formula. Not too bad. We're going to remember this more as a process, though, which we'll show in a few seconds when we do our first example. But what this does is this tells us how to differentiate multiplication of two variables. So what we have here is we're trying to differentiate, so that's what the ddx means, and we have two functions of x. We've got our first function, capital F of x, and then we've got some other function, the second function here, capital S. And it's not explicitly stated, but there is multiplication going on right in the middle there. So that's what the product is used for. It's used to help us differentiate when we're multiplying two variable terms. So what you want to look for here is a function with multiplication of variables. And we'll see an example. So sometimes you might be able to actually just multiply the variables out, but other times you might not be able to. So we want to keep in mind that when we're differentiating, if we have a variable term times a variable term, we got to be careful with how we actually do that multiplication. And what this rule says is we can differentiate the first part of this, keep the second function unchanged, then we add in the first function unchanged, and then we differentiate the second function. So a way to kind of think of this is in order to see how much the product f times s changes, we kind of look at just the change in our function f. We keep s the same. Then we look at the change in our function s, and we keep our function f the same. So this is the product rule. And we'll see how to kind of implement this. And actually, we'll come back because I do want to mention one other thing. But let's try an example. So let's look at example 1. We want to differentiate this function y. And what's going on here is it's the function 2x squared minus 5x times 3x plus 1. So what we actually have here is a product of variable terms. There's variables over here. There's variables over here. And right in the middle there, even though it's not written, there's multiplication. So we got to use our product rule. All right, so let's try it out. So how is this going to work? Well, we're going to calculate y prime. So we're doing the derivative. So let's call it y prime. And a way to kind of remember the product rule is to just write down two copies of your product. So we're going to have 2x cubed minus 5x times 3x plus 1. And then right next door, we're going to do a second copy. Leave a little space here, though. Leave a little space there. So we're going to have our 2x cubed minus 5x times 3x plus 1. So we've got two copies of our product. And then in the first copy, we're going to apply the derivative to the first part. And then in the second copy, we're going to apply the derivative to the second part. And then with product rule, we put a little plus sign in the middle. And so what we've done, this is the product rule. We've differentiated that multiplication that was in the middle. So now we still have to differentiate this and we still have to differentiate this, but now these are things that we can just do. No special rule required. So let's differentiate this first term here. When we do that, we get 6x squared minus 5. And then the term outside the brackets here we're done with, so that just stays the same. This term is outside brackets, so we don't have to do anything there. So that stays the same. And then finally, we have to differentiate this 3x plus 1. Derivative of 3x plus 1 is just 3. And that's it. We're done. That's the derivative. Now, if we wanted to, we could simplify this down, but that's perfectly fine. Now, one thing to kind of remember with product rule is a lot of times we want to be careful with parentheses. So in this case, this case, this case, this case, this case, and this case, we don't need them here, actually, but we need the parentheses. So in all of those, we need all of them. So we want to make sure everything here is getting multiplied by everything here. And everything in here is getting multiplied by that 3. So just kind of be careful with parentheses. So that's product rule. So it's the derivative of the first part of our product times the second part plus the first part times the derivative of our second. And that's what the formula tells us here. Now, it's a very natural thing, so kind of a little warning. The derivative of a product, so let's say we had a product of two variables, and let's say we were trying to differentiate this. It's very tempting to say that this derivative is just the derivative of the first piece times the derivative of the second piece. Very, very reasonable thing to think. Actually, this is what, when they first were developing calculus, this is what they originally thought. And unfortunately, this is actually incorrect. It's not equal. So when we have a product of variable terms, it's not just the derivative of the first term times the derivative of the second term. It's this more involved rule. All right, so we want to be careful of that. All right, so let's try the other derivative rule. Let's look at the other derivative rule. And we'll try some more examples of this in class. Excuse me. So like I said, we'll try more examples of this. We'll spice it up. But the other derivative rule I want to look at is the quotient rule. And this really can be proved from the product rule and chain rule. And you can kind of see when we go through this, you'll be able to see remnants of the product rule in here. So the quotient rule, well, it tells us how to differentiate when we have a quotient, when we're dividing variable terms. So what you want to look for in order to use quotient rule is you want to look for a fraction with variables on both the top and the bottom. And that's what we have in this general formula here. We have the top function, and then we're dividing by a bottom function, and conceivably both of these have variables in it. And we're trying to differentiate this whole thing. And so the same kind of warning applies for quotient rule as what we mentioned for product rule. So it's very tempting to think that if we had a fraction here, so some top function divided by some bottom function here, we wanted to differentiate this whole fraction, very reasonable thing to think, well, let's just take the function on top and let's differentiate that. And then let's take the function on the bottom and let's differentiate that. And we'll just say, well, the derivative of that whole fraction is just the derivative of the top function divided by the derivative of the bottom function. Very reasonable thing to think, but just like product rule, it's unfortunate that's incorrect. So instead what we do is we have this kind of more involved formula. And we're going to kind of see how to use this formula. You can kind of see the numerator here kind of looks like the product rule. So we'll come back and talk about this formula a little bit more in a second. But let's try an example to see how this works. So let's try example 4 here. So we want to differentiate this function y, and it's equal to x divided by 2x plus 3. So the first thing we want to look for is, well, we have a fraction, and there's variables on both the top and the bottom. So we really only need to use quotient rule if there's variables in both places, which this one has. So we're going to calculate y prime. And to do this, we're going to use quotient rule. So let's see how the quotient rule works. So we'll call our derivative y prime. And it's going to kind of work like product rule. So we're going to rewrite this fraction. We're going to write it as a product. So it's going to be top function times the bottom function. And then just like product rule, we're going to do 2 copies of that. So we'll have a second copy here. Top function times the bottom function. Leave a little bit of a space there in the middle. And then just like product rule, in the first copy, we're going to apply the derivative to the first part. And then in the second copy, we'll apply it to the second part. Now where this becomes a little different is with quotient rule, instead of plus sign in the middle, we put subtraction. And so the subtraction here is something we have to be careful of because the order actually matters. And then with quotient rule, we make this into a big fraction, and we take the original denominator and we square it. So our original denominator here was 2x plus 3. So we end up with 2x plus 3, and then we square it. All right, so kind of the same setup, though, as product rule. So now we've kind of differentiated our way through the fraction. So now we just have to do each of these kind of pieces of it. And these ones are easier to do, no special rule required. So derivative of x is just 1. And then derivative of 2x plus 3 is just 2. And that's it. I mean, maybe we simplify. So, you probably get rid of the multiplication by 1. We don't normally say that. Maybe clean that out. And I might write this as 2x, but perfectly good. Just leave it like that. So for right now, when you're doing these, don't worry about trying to simplify this down. As soon as you're done differentiating, you can just stop. One thing with quotient rule, you're always going to be tempted to do some canceling here. And it doesn't work out because in order to cancel out a 2x plus 3, yeah, we've got a 2x plus 3 here, but we'd also need a 2x plus 3 over here. So every piece in the numerator would need to have a 2x plus 3 in order to cancel it. So normally you're going to be tempted with quotient rule to kind of do things to the denominator. Don't. Just leave it as is. So don't try to multiply this out. Don't try to cancel. It doesn't cancel like that. So just to be careful. So normally just leave it like that. And that's our quotient rule. So quotient rule, you can kind of see remnants of the product rule in there. So it's the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function. Make that into a big fraction, and then we square the original denominator. Way to kind of remember this rule, besides remembering it as a process, kind of similar to product rule, there's a little rhyme. So sometimes you might have to break this out. So the rhyme goes, let's see, low, D high, well, it's already bad. We'll get there. Let me write it out first, and then we'll say the rhyme. So it's low D high minus high D low. Draw the line. And square the low. All right, so put it all together. It's low D high. it's still going to be bad. Low D high minus high D low. Draw the line, square the low. So that's what we're doing here. It's the bottom function times the derivative of the top. So the low function, derivative of the high function, minus the high function, the function on top, derivative of the low function. Make a big fraction, draw the line, and you square the low function. So a way to remember the quotient rule. or another way to remember it. All right, so I think that's a good place to kind of break, but we're going to try more examples to get more practice using these product and quotient rules in class. So we'll see you then. Bye-bye.